Hello there. It is me back at it again, and today. Oh crap! What's happening? We're doing trigonometry. Chamgus is doing his own trigonometry area. Here we are with me. If you don't know where we left off, you can watch my last video. I'll give a summary of it. We learned what radians were, and we learned how to calculate sine values for those radian values. That was a confusing explanation. Just you can watch the video. Okay. No more what you will learn stuff. I don't know why. But you need to know how to calculate sine and cosine values for special right triangles on the unit circle, and how to convert from degrees to radians, radians to degrees. Alright, so today we're going to be doing a little bit more practice with radians, and then we're going to be getting into some fun stuff with you know, cosecant, cotangent, secant, all that jazz. Right? Let's do this then. Chamgus and Box. All right. Let's start with some radians. Okay. So I'm gonna be teaching for this is gonna be like a 2-minute lesson max. Okay. So we're setting a timer for 2 minutes. We're going to start at exactly 2 minutes because 2 minutes kind of nice. So talk amongst yourselves. 5, 4, 3, 2, 1. Pew. Let's begin. Okay. So let's say I want to convert. Well, not convert. Let's say I want to find the number of rotations and what's called, I believe it's called the relative angle or something. I don't know. But I want to find, okay, so let's say I have a number, a radian bigger than 2 pi, right? That means it's going to go around the circle once and then loop back. Let's say I want to find the number of, oh crap, this is going to be 2 minutes. Okay, let's say I want to find, well, this is going to be the lesson. Let's say I want to find the number of rotations, like how many times it rotates around, and what the angle is going to be afterwards. And then we can loop that into finding the unit pair, the ordered pair, but that's very simple because you can calculate the y and x values. So we're not going to find the other ordered pair. Let's say, let's start off with a simple one. 6, oh my god, why can't I write 16 pi? How many rotations? And then what's the angle afterwards? Well, obviously what we're going to want to do is, well, find how many times it goes into 2 pi. This one's divisible by 2 pi. So it goes into 2 pi 8 times, so 8 rotations. Right? And then so 8 rotations, and then the angle is going to be 0, right? So let's say we have another one. Let's do something pretty simple still. 17 pi. Well, we're going to have 8 rotations after we divide by 2 pi, and we're going to have pi remaining. So the angle is going to be pi, and we're going to have 8 rotations, right? You see where this is going, right? Say we have 51 pi over 2, right? Divide, so how many times did that go into 2 pi? Well, you divide by 2 pi, right? So 51 by 4 times, so that's going to be what? 52 is 14, 4 times 13, so it's going to be 4 times 12, 48, so equals 12 rotations. Yep, 12 rotations, and then what's going to be the angle afterwards? Where we're going to have, what? Minus 3 pi over 2 would get us to 48 pi over 2, which is 12 rotations. It's going to be plus 3 pi over 2, so the angle is going to be 3 pi over 2. And that concludes the mini lesson. Well, kind of. You can do, you can convert this for like pi over 6 and stuff. If you have 51 pi over 6 or something, well, like 52 pi over 6, you can convert it. You just basically, the gist of it is you divide by 2 pi, you find the remainder and the number of times it goes in, and that's what you want to find. And this will be helpful on occasion. So, there we go. That was kind of a pointless lesson, but it's necessary. It is the required stuff. Next up, the fun stuff. Right? It's 7 p.m. Dang. So let's say, oh my God, it's 5 minutes and 30 already. Okay. Let's define every single thing. Okay. So we have sine x on the unit circle. Mute yourself. Cotangent of x equals, right? Whoa, do you see that x? It looks like it's 3D. It's kind of cool. Okay, anyways. Let's find this. On the unit circle, sine of x equals y coordinate, right? Cosine is the x coordinate. Tangent, y coordinate over the x coordinate. Or sine over cosine. Right? Cosecant, 1 over sine. Secant is 1 over cosine. And then cotangent, you guessed it, 1 over tangent. So this is going to be much shorter than the last one. Actually, maybe it won't. We'll see. So there's all of our definitions, right? Well, cotangent can also read as cosine over sine. And then so let's do this. Let's do this, and then we're going to be doing some other stuff, and we're going to be going over some basic properties. Ready? Okay. So let's do a simple one, okay? Oh God. Okay. So let's say find cotangent at, that's a horrible at, Jesus Christ. At how about 4 pi over 3, right? And so how I like to describe it, right? How do I like to well, let's bring back our unit circle. Maybe we don't want a unit circle, actually. Let's just make a square again. Let's go over here and go to 0 angle. Man, I waste a lot of time here. Alright. Bam, bam, bam. Speed run. That's horrible. Sure. There we go, right? Should I draw the unit circle? Sure, why not? What? There's nothing to lose. But your shoes. Okay. Find cotangent at 4 pi over 3. Okay. Well, we want to find where 4 pi over 3 is so we know negatives and positives and all that whatnot. However, what we do know, and this is a very useful trick, is that if it ends in something over 3 or something over 6 and it's not simplifiable, then we know that it's going to be some form of a 30, 60, 90 triangle, right? Because all of the things that end in over 3 or over 6 are going to be 360 degrees over 3 times something, you know? Or, yeah, something like that. Something of that sort. And so this is very, very useful. So that means that it's going to be some form of a 30, 60, 90. As we know, the ratio for a 30, 60, 90, if the hypotenuse is 1, which it always will be, remember this, it always will be in the unit circle. Not in, like, general trigonometry, but in our unit circle trigonometry. That's a horrible 30, 60, 90. My God. I'm just not having a day. Okay. Where are... Oh my god. Okay. Let's draw our triangle here. Bam, skabam, skadoosh. There we go. 30, 60, 90. Right? If this is 1, this is 1 by 2, and this is root 3 by 2. So we know that if we're trying to find cotangent, well, we know that that's 1 over tangent, or cosine over sine, right? Because it's 1 over sine over cosine, which is cosine over sine. So let's do cosine over sine, so we don't have to calculate tangent. Cosine over sine. So we need to find the cosine and the sine, right? We know that it's going to be some form of root 3 over 2 and 1/2. However, we don't know which one's sine, which one's cosine, which one's negative, which one's positive. So let's first kind of graph this line, this angle, right? 4 pi over 3. Well, we know which quadrant. It's a third, because it's between pi and 3 pi over 2. So it's somewhere in this... Where did my circle go? Okay, give me a sec. Oh my god. Did you guys see me delete it? There's my circle. We know it's going to be somewhere in this area. Oh my god. Okay. Somewhere between here and here. I thought I clicked away. Right? And let's think. This is pi, right? This over here is going to be 5 pi over 4, and this over here is going to be 3 pi over 2. Oh my god. Dude, can I just, like, not exist sometimes? 3 pi over 2, right? So let's think, right? The only other two angles that we know will end in over 3 or over 6 are going to be here and here, right? So we need to find where it's in between. Pi and 5 pi over 4, pi and 4, and 3 pi over 2. Well, 4 pi over 3. Well, let's multiply top and bottom by 4. 16 pi over 12, and then 5 pi over 4 becomes 15 pi over 12, meaning that 4 pi over 3 is larger, meaning that it's, okay, it's going to be this angle over here, right? And this kind of deduction and inequality using is very useful. So we know that it's going to be over there. That means that the y value is going to be the bigger value, and the x value is going to be the smaller value, and they're both going to be negative, right? So let's draw a line here. And this is 30, 60, right? This is 1. This is the longer side over here. So this is going to be root 3 over 2, but it's negative. This is going to be negative 1/2, right? Look at us go, right? Because we know the ratio, and we know that in the third quadrant, both x and y will be negative. And so we know that they're both negative. Okay, so we know the cosine is negative 1/2, and the sine is negative root 3 over 2. So let's write that down. Let's write negative 1/2 over negative root 3 over 2. Right? 2's cancel. Negative 1 over negative root 3. 1 over root 3. And you don't have to really rationalize the denominator. You can, but why? So we know that cotangent at 4 pi over 3 is 1 over root 3. Let's find all the values, shall we? Because it's very fast, right? Sine x equals cosine x equals tangent x equals cosecant x equals secant x equals and cotangent x. We know cotangent is 1 over root 3. Because cotangent is 1 over tangent, that means tangent is 1 over cotangent. So they're the reciprocal of each other. So tangent equals root 3. Cosine is negative 1 over 2. What is this? Sine is negative root 3 over 2. Secant and cosecant are the reciprocals, but don't get them mixed up. This is very common. Cosecant is often paired with cotangent. Over cosecant goes with sine, secant goes with cosine. So that means cosecant is the reciprocal of sine. Reciprocal of sine is negative 2 over root 3. Reciprocal of cosine is going to be negative 2. And there we go. We found the values at 4 pi over 3. And hopefully you don't simply go off of formula. I mean, actually you not really do, but like you understand what's happening here. What we're doing essentially is we're saying that because so the cotangent at 4 pi over 3, right? This is not necessarily 1 in every case, right? I mean, this angle goes off to infinity, right? However, they will all be similar, right? Because this inner angle will be the same, and this angle going down from it will be the same. So all of those triangles will be similar. So we go ahead and why not just say that this is 1 to make it much simpler on ourselves, and then we know that the sine is opposite over. Sorry, it cut off there. Anyways, and that's what's really happening here. Is that it's all just a ratio. Sine and cosine are a ratio. They are not a value. They are not a length or width value. They are simply a ratio, and that's what's really incredible. And we'll see that when we graph sine and cosine, which is much simpler than it sounds. You'll see that they are a ratio, and it's very nice that it goes like this. And I don't think about these as think of them as x and y coordinates. However, don't think of these as lengths. They are lengths, but rather think of them as ratios to the hypotenuse, because the hypotenuse is 1, so the ratio is going to be just the value, right? But don't think of them as ratios, because then when you do it as, if this length is 4, if the hypotenuse is 4, you're going to multiply these by 4, and that's simply not correct, because it's asking for the ratio between the opposite and the hypotenuse. So hopefully you understand sine and cosine like that. Hopefully, what else you understand is what cosecant, secant, and cotangent are. I kind of went over them pretty fast, but and there's lots of properties that you have with these guys, but it's simplified. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent, or cosine over sine. Right? And then, as for finding the angles, this is just super important. Find blank at blank. This is going to be useful for inverse sine, inverse cosine. This is going to be useful for when you get into higher level trigonometry. It's so useful, right? And so basically what we're doing here, right, is we're saying, we find whether it's a 30, 60, 90. We find whether it's a 45, 45, 90. If it's a 45, 45, 90, then we know exactly where it's going to be without doing any aforementioned math.
Yeah, sure. Alright, so I need help.
Oh, I'm very sorry. It cut off there. But what was I talking about? Right. We know whether it's a 30, 60, 90 or a 45, 45, 90 by looking at the denominator, thinking about where that's going to be placed. We also know which quadrant it's in. If it's a 45, 45, 90, you know exactly the angle at which it's going to be, which part's negative, which part's positive, all that. If it's a 30, 60, 90, then you can figure it out using an inequality as we did here. We know that it's bigger than 5 pi over 4, and it's smaller than 3 pi over 2, so it's going to be over right there. And so that's what we do. Then we simply assign our values. We start finding, with our 30, 60, 90 at least, we assign this hypotenuse to be 1. We find the short side and long side based on how it's placed. If it's between 45, if it's between, an angle and and a quadrantal, and the angle is smaller than quadrantal. Well, that's a bad explanation. I'm sorry. You know if it's long or short. You can tell um, simply because of how it's going to be placed in your coordinate plane. Before you're ready for a higher path, you should be able to visualize it, but for now, this is good. And this is really good. And so we have that. And then we assign values. We simply solve the equation. And by finding just this triangle, we can find sine, cosine, tangent, cosecant, secant, and cotangent. And we can, I mean, it's really, really useful. So I would recommend, if you really want to get good, you practice a lot of this. I mean, you can use, like, I don't know if AOPS has some, but, you know, Khan Academy, I'm sure, has some. You need to, if you practice this, I don't know if they teach it in the same way, but this is just so useful for later trigonometry. And then once you do that, it gets crazy. You can find side lengths of triangles that aren't even right triangles, and it works so well, and it's just incredible. So I would recommend you practice a lot. You practice this strategy if you'd like. You can just watch my video, I guess, again. Hopefully I was able to explain this well. And I will see you next time. Hail Gregor gone.